Flexicell in Ashland has been bringing robots to life and doing so for over 25 years. Stay tuned for a very close behind-the-scenes look at state-of-the-art robotic integration right here on Made in Virginia. Made in Virginia is brought to you by at Union Bank and Trust. We salute the dreamers, the thinkers, the doers, the believers, the builders, and the makers. Thanks to your vision, hard work, and innovation, you make Virginia shine. Union Bank and Trust, a partner of Virginia Business and a proud supporter of Made in Virginia and Virginia Public Broadcasting. T-Mike, honoring Virginia's manufacturing heritage and proudly supporting Made in Virginia. T-Mike, we drive industry. And a very special thanks to Made in Virginia supporters. The Woodrow Wilson Presidential Library and Museum in Stanton, Virginia. A truly unique Made in Virginia experience. The Greater Augusta Regional Chamber of Commerce, a partner for success. And the law offices of Allen and Carwile. Meet the robotic integration team of Flexicell, located in Ashland, Virginia, just 15 miles north of Richmond. This team of world-class engineers and industry leaders bring robots to life every day. The Flexicell team designs, builds, and integrates custom robotic solutions for manufacturers to accomplish the task of picking, placing, packing, and palletizing just about any product in any shape and size, and do so continuously 24 hours a day, 7 days a week, with the industry's highest mean time between failure rate.
So at Flexicell, we bring robots to life, and the way we do that is, we do the mechanical engineering, we bring all of the pieces together, and when we get our full cell put together, and we're able to let that robot move and do the job within the solution that we sold to our customer. That's what we mean by bringing robots to life.
I like to tell people that I help bring robots to life. The robots are basically dumb pieces of equipment until we're able to put pieces around them, bring electricity to them, program them, and then actually, as I like to say, bring them to life and see them perform the tasks that they were meant to do.
The challenge in the fiercely competitive world of robot integration is always to find the most efficient, fastest, safest, and most reliable way to get the job done. So once the customer has committed, the team gets to work designing the robotic integration system, or what these professionals call a cell. Typically, it takes about 6 months for a cell to come to life and go to work at the customer's site.
We're responsible for designing all aspects of the mechanical components. So we're responsible for designing everything mechanical in the entire cell. Everything is designed in 3D software. Everything is manufactured here at Flexicell.
To say there are a lot of moving parts would be an understatement, and many of the robotic cell's development and build processes are undertaken simultaneously in this high-tech Virginia robotics shop. These complex machines that require a vast array of precise working connections come together in perfect order.
Pretty much everything you see in here is built in-house. I mean, we will buy components as necessary. But a majority of the components you see on the machine are fabricated right here in our facility. One thing that does for us is it gives us greater control of what we are putting together. You know, we're not waiting, we don't have to wait for a vendor to put it in his window of opportunity to deliver it to us. We find our own window of opportunity based on what our backlog is as far as projects on the floor at the time.
Think of the robot as the shoulder, upper arm, elbow, and forearm or quill of the machine. What Flexicell designs, builds, and integrates are the conveyors, servo tooling, and pallet handling equipment that surrounds the robot. But most importantly, Flexicell designs, builds, and integrates the wrist, hand, and fingers of the machine. They are called the end-of-arm tools, and they are capable of intricate, precise, repeatable movements within a wide range of capacities.
We focus on everything around the robot. So we buy a commercial available robot, which you see commonly used in the automobile industry already for many years, and we basically make that robot a packaging machine. So conveyors, safety guards, dispensers, pallet dispenser, case dispenser, group products together called a collator, so grouping multiple products together, and then the end effector, which is basically a gripper, a hand of the robot to pick products.
In order to make the robot work and pick things, we have to design an end-of-arm tool. That can be so it would pick product with vacuum or a mechanical pincher, if you will. They are all unique to every single job, and that's dependent on what product we're handling. Typically, cases are picked by vacuum. Consumable goods like bags of liquid, we might pick that with either a vacuum cup or a mechanical pincher.
The process starts with the cutting of component parts to their required shape and size. This is performed with great precision using a laser cutter. Once laser cut, some of the parts are bent and machined for special applications, weldments, and operations. One of the first components of the cell to be built is the base. It is the table upon which the robotic system will be mounted. It is built to seismic specifications, rigid and strong, typically with a massive 1-inch thick rolled steel top.
Well, the base is so critical to the robotic aspect part of it is because that's kind of defining you want to call it a base, I guess you would call it the solid footprint that our automation and our robotics comes from, right? That base is specific, more than likely, to whichever project we're on, because that has to be designed with the reach of the robot in mind.
The base is sort of the core of the structure, and it depends on the application because everything we do is custom designed. But you start with the robot and what the robot is mounted to, the robot base. And then you have conveyor systems that come off of that base that are built around that to support incoming products, pallets, cases, different objects. And then you'll have safety guarding, which is built around that. And then you'll have the tool itself, which is really the heart of the system. Every project that we do has a little bit different requirements depending on the unique application on the customer. We may actually have two customers with very similar products. You might have a soda can and a soda bottle, which seem very similar to most people, completely different from a tooling standpoint. So the heart of the system is how we design the grippers or the end effectors. And that's sort of the process that we go through, working from the center of the system out to the end of arm tooling and then the supporting equipment around that.
Parts which require rotational motion are tooled on the CNC machine. Steel parts are powder-coated, leading a corrosive-resistant, high-quality finish. These parts, along with a wide array of motion control assemblies, including servo motors and sensors, come together to make the end-of-arm tool, which, when completed, is bolted onto the quill. Flexicell's customized end-of-arm tools come in many shapes and sizes and can be designed to accomplish a myriad of tasks, from vacuum picking to gripper, magnetic, shelf, and layer-style picking. Layer picking is put into use here for the handling of these beverages.
On that particular end-of-arm tool, that went through a design process, and through that process, we try to simplify as much as possible. when it was adjusted to be used, we were able to simplify to the point where there's really only 2 devices on that end of arm tool, one being a servo and the other being a pneumatic valve. So depending on the complexity of what we're trying to do and what the customer is asking us, we change that design, that solution, to match what the customer's challenge is.
The conveyor system usually contains a mix of off-the-shelf and custom parts. The input side of the system is responsible for providing a steady stream of products to the end-of-arm tools. Here, a Flexicell custom-built cross sweeper continuously feeds the beverage packages, which are collated into a 4x3 configuration. 12 packages make up one layer, which is picked and placed by this layer-style end-of-arm tool. This robotic cell can complete 5 layers in 60 seconds. A pallet dispenser is connected to the cell, which provides a steady stream of pallets ahead of the picking and placing. Once in place, the cell stacks 7 single layers of product onto the pallet, which then exits the cell and is then turned 90 degrees on the pallet turntable and sent down the exit line to be prepared for shipment. Just to get the products to this point takes a great team effort. The robotic cell system is doing its job at the optimal speed. But remember, all of these precise movements and operations must be powered, controlled, and must constantly provide real-time feedback to itself and to the operator via the human-machine interface. This assures a smooth, safe, and speedy operation is maintained.
So the HMI, the human-machine interface, is the operator's window to how a system works. I always equate it to a bank ATM to our customers, so that to let them know if their operators can run or can work a bank ATM, they can run on one of our systems, because it's the same technology. It's a touchscreen technology, color touchscreen technology, and it gives them prompts on the screen and little boxes to push, just like at an ATM, and it walks them through the process of how to start the machine, how to make changes to the machine, how to recover from the machine. And then from a maintenance standpoint, it has a lot of useful information where they can go in and do diagnostics on potential problems. They can get history on faults that have occurred. They can get maintenance logs, how long something's been running, maintenance schedules, anticipated failures, and a lot of detailed information that's in behind the system. So from an operator standpoint, it's very, very simple. They just run a touchscreen, but there's a lot more power and capability behind that that allows the system to work very well and look like a very fancy, complicated system, and it is, but to the operator, it's quite simple. They walk up to the touchscreen, they press the button, and it tells them to touch, and the system just runs.
Long before the robot ever starts moving, much less with any speed and precision, the electrical panel is assembled. It contains the programmable logic controller, the robotic system's brain. It is programmed to accomplish each of the cell's motions and operations, and do so in perfect rhythm with one another.
The PLC is the cell controller. It controls the whole system. It controls the robot, and it also controls the conveyors, the inputs coming to the cell. The inputs coming to the cell, like the photo eyes, the proximity sensors. It also communicates with the operator touch panel, the HMI, to allow the operators to both see what is happening within the cell and also to control and give input back into the cell.
The cell is now completed. All the custom parts for the conveyor and the end-of-arm tool are built and wired. The hoses and sensors have been assembled and attached. The infeed and exit conveyors are in place. It is now time to run an internal factory acceptance test. This is done with customer-supplied original products to assure accuracy of each step in the process. Some fine-tuning usually takes place, and additional internal factory acceptance tests are completed. Once satisfied the robotic systems meets and exceeds the customer's exacting specifications, the Flexicell team is ready to bring their creation to life for the customer. For this team of professional robotic integrators, Virginia is the place to be. And you can be sure the Flexicell team, with their state-of-the-art designs, industry-leading performance and reliability, could locate themselves anywhere in the world.
In the beginning, we hardly had any customers in Virginia, even in Virginia, not even in Richmond. It's only after a few years that we realized that we were taking orders in faraway states like Minnesota, and a company out of Minnesota was trying to get an order next door to us. And then we realized we had to focus more on Virginia, and we did.
I would say the majority of our employees are from Virginia. We do have probably several controls engineers that are from out of state. Obviously, Hans is from the Netherlands, as well as a few other people here. I'm from Virginia Beach. I've always taken pride in, turning out a good product for the people of Virginia. We have a lot of companies that we've provided products for in Virginia, and we've gotten repeat business from them.
I'm originally a Midwesterner, and I came out here to Virginia because Virginia is such a great state. I think I've lived in a number of places in the United States, and I think Virginia has a very diverse offering to the people that live here. I mean, if you look at it, Richmond in general, 2 hours, I can be in the Shenandoah Valley, I can be walking a trail on the Blue Ridge Parkway. 2 hours, maybe 3 hours, I can be in DC now because 95's, what it is. But I can be on the beach in a couple hours, There's culture, there's good. Richmond has such a diverse variety of restaurants and opportunities in it. I just find Virginia for me, Virginia is home. I mean, I'm glad we're here.
I think Virginia is great. I came here 2 years out of college, and what I found is a young town I've been here nearly 30 years. It's grown. It is a fun place to be. It is easy to do business in Virginia. The talent pool is here. So maybe there's other places to go, but this is a great place to do business. The infrastructure in the area, meaning the roads, you don't have traffic. You can come to an area like Ashland, Virginia, like we are right here. It is not busy, not crowded. We have a beautiful office park, but you're close enough to whatever you need. You're 20 minutes from the city, you're 20 minutes from the suburbs where people live. To me, it's perfect.
Virginia, for me, this is a very special place. I was not born and raised here, but I've come here for this technology, which I was a little surprised when I came here that this technology existed in Virginia. And it is a little bit of a misconception that people have to go outside of their hometown to find technology. But there's quite a big hub of technology in Virginia. There's a number of different automation companies that do things like we do. I actually came to Virginia to work for a bakery automation company, and then after a couple of years there, came to work for this company doing robotic automation. But we have a number of great suppliers here in Virginia that can get us the technology and the parts that we need. We have good technical support from those suppliers in Virginia that can get us the cameras and the vision systems, understand the servo automation and some of the higher tech programming that we need. And we have a great resource of employment talent from the area. A great number of schools. VCU is right here in downtown Richmond. We have a number of engineers that have come to work for me through VCU. We do a lot of internships with both VCU and Virginia Tech and UVA. We also do a lot of work with the high school students in this area in doing senior projects. We bring kids in that want to do mechanical engineering or programming engineering or electrical engineering. We expose them to the real world industry of automation and manufacturing as it relates to the industries that we work within.
Flexicell is also a great community-minded company that raises the bar at every level of its involvement. Mentoring Virginia high school robotic teams in the national first robotic competition and having reached the RFC World Championship with Sparky 384 10 years running. These robots must be built in 6 weeks, shoot balls at a target, pick up and place gears from off the floor onto a rack, and climb a rope.
I am overwhelmed at the commitment of our mentors that work at Flexicell, combined with the leaders from the Richmond Public Schools and the students. I work a fair amount of hours, and when they are at the peak of their season, these kids are here 6 days a week. And so they've gone to school, they're here Monday nights, they're here Friday nights, they're here on Saturdays, and they are so focused on winning. The First Robotics teams, we have 2 teams that we sponsor, and they both did very well in the district, regional, and world championship competitions this year. I had the opportunity to go to the regional competition, which is at the Siegel Center this year. That was the first competition I've ever seen. The excitement, the passion that these students show, it is really amazing. They take it very seriously, but they have a lot of fun. It is such a great experience for these kids who are interested in the engineering fields. They are making the parts here in our manufacturing operation. They are writing the code. They're having some of our specialists work with them as needed. And to see it all come together it makes me proud to know that Flexicell is giving them a place to do this work and giving these kids an opportunity to do something that lets them follow their passion. And let's face it, they're doing something with their time that is so worthwhile, where if we weren't doing our part, who knows what they would be doing on Friday night. So I like that part too, is having 2 young kids.
And it's a program that we've been supporting for such a long time, and it really has brought kids. I actually have people that work for us that came through first in high school, went to local colleges, and then are now working for me as engineers. And that, to me, is sort of the completion of the circle. And those engineers are now working with kids in high schools in the first program. So it's a full circle program that works great for us. So having that outreach in Virginia and that community involvement here, it's really been good for us. And it's allowed us to showcase the type of talent that we have locally, and to be able to bring those people into the fold in a technical world that people may not normally associate with this area, but there's a lot of high tech here. So the future of robots, I think, is really wide open. The cost of robots, just like every other electronic piece in the world, has come down dramatically. Our ability to apply robots into situations that were unaffordable 10, even 5 years ago, has come down. Just like any computer and automated system, the cost of it is lower. So you can utilize it. You can put more robots in situations for automation that do not require as high of a payback. And because robots are much more user-friendly and more state-of-the-art, they require less attention from a technical standpoint. So people with less training from a higher technical standpoint are able to use robots more and more.
You have to imagine, when I started 25 years ago, there were a few other companies, much bigger companies than Flexicell was. And I always looked at them, and if we ever could be as big as they are. We had maybe 5 or 10 employees, and they had 100 employees. All those companies are no longer in business. We have survived them. So that makes me proud that after 25 years, we have grown slowly and are what we are today.
Now entering its 25th continuous year in business, Flexicell is leading the industry with its state-of-the-art applications, unbridled successes, and unsurpassed reliability. Flexicell, bringing robots to life. And it's all made in Virginia. Today, the word robot is in common usage. But what is the origin of the word robot? Is it A, Scandinavian for the action of rowing a Viking boat? B, Czechoslovakian, meaning a slave or drudgery? C, American from Walt Disney, a phrase he coined when describing his fully automated puppets? Or D, Old English, as in the word used for the winches used to cock catapults? The answer when we return. Made in Virginia is brought to you by At Union Bank and Trust, we salute the dreamers, the thinkers, the doers, the believers, the builders, and the makers. Thanks to your vision, hard work, and innovation, you make Virginia shine. Union Bank and Trust, a partner of Virginia business and a proud supporter of Made in Virginia and Virginia Public Broadcasting. T-Mike, honoring Virginia's manufacturing heritage and proudly supporting Made in Virginia. T-Mike, we drive industry. And a very special thanks to Made in Virginia supporters. The Woodrow Wilson Presidential Library and Museum in Stanton, Virginia. A truly unique Made in Virginia experience. The Greater Augusta Regional Chamber of Commerce, a partner for success. And the law offices of Allen and Carwile. So what is the origin of the word robot? The answer is B. Czech playwright Karel Čapek introduced it in his 1920 hit play Rossum's Universal Robots, and it was taken from an Old Church Slavonic word robota, meaning forced labor or drudgery. If you would like to learn more about today's episode or suggest a Virginia manufacturer for the program, you may visit us at madeinvirginia.tv and at wvpt.net.